Hi, my name is Dr. Ebrish and I am an assistant professor at the Electrical and Computer Engineering Department. I am interested in understanding the electron transport across different material systems. My group works on heterogeneous integration, which is basically a technique that we use in order to leverage all the advantages from different materials to augment each other. For example, silicon is a very good material for computing, and we're not trying to build transistors that will compete with that. But we can use wide-bandgap materials like gallium nitride, for example, to build high voltage transistors or radio frequency transistors. Let's go to my lab and see what my students are doing. My group builds transistors in the clean room, and then they bring them here for electrical characterization. This is an air station, which means that the environment is not really controlled, but we can measure the IV characteristic or the CV characteristic using the semiconductor analyzer. Next, here we can do a more controlled environment characterization in a vacuum chamber. This vacuum chamber is also a cryogenic chamber that can go from 10 Kelvin to 500 Kelvin. In this measurement, the devices will experience the swath of temperature under vacuum. So we are controlling the environment and we can understand the interfaces between materials and gauge their reliability. And after that, this is basically the heterogeneous integration technique or tool that we are using. It's called microtransfer printing. Here we have two stages. One stage where the source wafer will be on. This wafer has released devices already that was released in the clean room by etching the sacrificial layer. And then the devices will be picked precisely from certain locations and transferred precisely to another location on the targeted substrate. If you are interested in joining my group, you will be playing with different materials, starting from two-dimensional materials like graphene to a wide-bandgap materials like gallium nitride, and integrating them heterogeneously with the microtransfer printing on silicon substrates. So, join EDGE.